Yo, what's up, everybody? Welcome back. Today, I want to implement UDP hole punching. The context here is I want a phone client for my Linux desktop, right? VoIP client, SIP client, whatever you want to call it. I think they all suck. I want to use my own. And it's also like a fun little thing to do, right? One of the things that we might want to do is we might want to call people, right? And so the protocol says, hey, I will tell you where to send your audio packets to me over UDP. And I will send my audio packets to you over UDP, right? But the problem is I don't know where I live, right? Because in like your typical network, IPv4 network, we'll say, there's like the like channel of me communicating to like another SIP client goes SIP server. There might be another SIP server over here. There might be me over here. There will be like my router. We'll call it R1. I talk to my router forwards a message to the SIP server, he sends a message to the other SIP server, he talks to the other guy's router, router 2, and then there's you over here, right? And if I'm like, I want to send traffic to you and you want to send traffic to me, we don't really know how to do that because the routers are going to change our IP addresses, right? So like if I go over here and I type IP adder, that's like a safe thing for me to do on stream because you are only seeing my local addresses, right? So there's not like enough addresses in the world for all of the computers with IPv4. So what they do is every router gets his own IP address. The router talks to the internet, and the router to all of the people on the LAN will hand out like local IPs. And so when I make a connection to like a TCP connection to like google.com, the router knows that like I have sent an outgoing connection, right? So I've like said like out please, pools, and he'll be like, oh, okay, well, you're talking to this guy. So if the guy sends something back to like whatever port I allocated, I'll just like send that back to the port that you allocated, right? So it's like he has like port 1, I have port 2, and I'm sending stuff out from port 2. The router like transforms that into port 1 and forwards it on. Bing, bang, boom, right? UDP is a little bit harder, right? Because UDP is stateless. So typically what's going to happen is if I'm talking to somebody that uses UDP out on the internet, I'll be like, send UDP, send UDP. And I'll have like some port, right? And the router will be like, okay, send UDP. And I will have like a port allocated as well. But because like there's no like transactional behavior here, the router kind of just has like a bunch of rules to kind of just remember that this happened and eventually like delete it, right? So as long as there's like traffic going over this connection, there should be like a way for whoever I'm talking to like send messages back, right? Now, you can kind of abuse this a little bit in that if I say like me, right, I've allocated port, UDP 100, right? Since UDP is like stateless, I can send a message to like guy, right? Just some guy. And the router will like allocate a routing table entry for this guy, and he'll say, okay, so like 100 on the left turns into like 1, 2, 3, 4 on the right? And so when guy sends back to 1, 2, 3, 4, it goes back to my port 100. Perfect. But because UDP is stateless, some routers, not all of them, but some of them will allow anybody to send stuff to 1, 2, 3, 4 and forward it back, right? So my understanding of like the magic of stun is that you talk to stun server. There's some guy, stun server. I say, yo, on UDP. Then he says back, you are public IP, right? Because like I'm behind a router, so I don't know my public IP, but he does because he just saw it, right? So he's like, hey, from my perspective, you're this guy, and then I'm like, sick. Okay, so whenever I'm negotiating with another peer through like a proxy server, like through this like SIP world, I like send this public IP to him with the port that I allocated for this, and like hopefully other guy can just like bypass this whole thing, and when you're doing peer-to-peer now, right? So the only thing that I need this external server for is like figuring out who I am and for like maintaining the connection state so that my router like thinks that I'm still talking, right? That's my understanding. We're pretty like hand wavy on everything here. But this is my understanding. So I think the plan of action for today is we like read the stun spec. Read stun spec. We try to construct a stun message to send out from a we'll say make so that it fits in the line. I've got my my VPS set up so that I don't leak my own IP, which is pretty sick. Send it, right? Get a response. Record response, and then parse and do whatever else we need to do according to the stun spec. This is the plan. And if we can get to the point where I can send a message to like on my VPS, hold on. I have set up a network namespace, right? So if I go like IP address, here is my VPS's public IP. This is public knowledge, so like I'm not leaking anything scary. But if I go into this guy and I say start a network namespace, and I go like this, now I have like a local IP. So it's kind of like just within the VPS, I've set up like a virtual LAN essentially. He should be able to like, I'm hoping that from within this virtual LAN, we can like send a UDP message and he'll get the answer, right? That's kind of like the goal for today. If we get there, we're very happy. Yeah, so that's the plan. Let's get moving and grooving. We probably won't read the whole stun spec. We'll probably just kind of piece together whatever pieces that we need. Okay, so session traversal utilities for NAT. Stun. Oh, nice. That's the abbreviation. It's a protocol that serves as a tool for other protocols in dealing with NAT traversal. It can be used as an endpoint, by an endpoint, to determine the IP address and port allocated to it by a NAT, right? So I've got my local IP and port. Stun tells me what the public version of that looks like. It can also be used to check connectivity between two endpoints and as a keep alive protocol to maintain NAT binding. So that part that I said at the end, didn't make it up. It's true. Very nice. Stun works with many existing NATs and does not require any special behavior from them. Stun is not a NAT traversal solution by itself. Rather, it is a tool that can be used in the context of NAT traversal solution, right? So there's like, stun will not necessarily work. So we should try to use it in combination with other techniques, like just raw proxies and stuff like that. The protocol defined in the specification provides a tool for dealing with network. We just said that. Wait, didn't we just say all this? Yeah, this is just what it said in the abstract. In keeping with its tool nature, the specification defines an extensible packet format, defines operation over several transport protocols, and provides two forms of authentication, right? So I think this works over TCP and UDP, which makes sense. Like we might want to have like a public UDP port or a public TCP port. That makes sense. It's intended to be used as one in the context of one or more traversal solutions. These solutions are known as stun usages. Each usage describes how stun is utilized to achieve the NAT traversal solution. Okay. Typically, usage indicates when stun messages get sent, which optional attributes to include, what server is used, and what authentication mechanisms to be used. Sure. So we might talk to like 10 stun servers and like just try them all and see what fucking happens. Interactive connectivity establishment, ICE, is one usage of stun, right? So I think that this is what we're going to end up using at like a higher level, is this like ICE spec, which uses, so there's like proxies that are involved in that as well, and then maybe there's something else as well, I can't remember. SIP is another usage of stun. Hey, we're SIP. In some cases, a usage will require extensions to stun. A stun extension can be in the form of new methods, blah, 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 blah. Okay. Overview. So there is a stun server. Public network. private network. Okay, so this is like top to bottom. So I am down here, you know, I have my router. There's another router in front of the stun server or something. JJ, thank you for the prime. Much appreciated. Here is one possible configuration. I don't think we need to look too carefully at this because I think it's just what I drew a second ago. So we have a client. The client connects to the private network through NAT1. Private connected 2 connects to the public internet through NAT2. Right, because like I guess my ISP might have like another NAT in front of my router. And then the server resides on the public internet from my perspective. Stun is a client-server protocol. It supports 2 types of transactions. One is a request-response. So I say, can you please tell me something? And he says an answer, in which the client sends a request to the server, blah, blah, right, that's what he said. Second is an indication transaction, in which either agent, client or server, sends an indication that generates no response. Sure. Both types of transactions include a transaction ID, which is a randomly selected 96-bit number. We should probably start writing stuff down, right? So there are request response, there are indications, no response, everything has ID. RRC, there's a decent article about this from Tailscale with diagrams, but I know you like the RFCs. Yeah, no cheating. We are no cheating allowed. We look at the source. You know, saying I like the RFCs is strong. I don't think I typically am like happy when I'm reading these things, but I think it's like a good skill to have. So this is how you can bypass your router's closed ports, firewalls, etc. Well, I think that the router can still like ban you from doing this. I think it's more like this is just how you can serve yourself to the internet without port forwarding is kind of more it. Okay, all send messages start with a fixed header that includes a method, class, and a transaction. Okay, so it sounds like there's like there's methods, classes. That's like a thing that we have to keep in our head. This specification just defines one method, binding, but other methods are expected to be defined in other documents. Got it. So it's like extensible in some way. The class indicates whether this is a request or a success response or an error response or an indication. Sure. Class is like, what the fuck is this packet? Followed by the fixed header comes 0 more attributes, which are type, length, value, extensions. Cool. Document defines a single method called binding. The binding method can be used either in request response transactions or in indication transactions. Okay, so you're calling a function binding, which can be used as like a hey, just letting you know, or like can you tell me something in response, I guess. So yeah. So when you're using it as a response, it'll like tell you your IP and port, basically is what this is saying, I think. But if we use binding as an indication, we're like using it to keep the binding alive. Makes sense. Because we need to prevent the router from like removing this entry from the routing table, but we also don't need the like response anymore. We know who we are. We're just like, hey, just like keep this shit open. Okay. In the binding transaction, a binding request is sent from a stun client to a stun server. When the binding request arrives at the stun server, it may have passed through one or more NATs. Yep. As the binding request message passes through a NAT, the NAT will modify the source transport address, blah, blah, blah. As a result, the source transport received by the server will be the public. Yep. I don't care about anything they're saying here, I don't think. They're basically saying like, yo, this shit changes. But like, if we put the fucking IP port in the body, the router won't fucking touch that. And it's like, yeah, okay, of course. We're talking about multiplexing with other protocols. I don't think I care. He's got a set of optional procedures called mechanisms. These include DNS discovery, redirection, blah, blah, blah. I probably don't have to care about this either. Huggo42, thank you for the tier 1. Almost a year, 11 months. Yeah, that's huge. Thank you for everything. No problem. I do it for me, and it's nice if that has some benefit to other people. Is this part of the doorbell phone saga? Yes. Yes, it is. We need to make calls to people, and the calls might be peer-to-peer. Or the calls should be peer-to-peer. So we need to resolve our public IPs. I don't think any of this seems worth reading. Okay. They've got agents who are an entity, right? These RFCs love talking about agents, right? They're like, you are a user agent client or a user agent server. You are doing a thing on behalf of a user, so you are a user's agent. Like, I don't care, like whatever. A client is an entity that sends some request. Yeah, we know what clients and servers are. We know what an address is. Reflexive, they were saying up here, was something about the like fucked up address as modified by the router. Yeah, so this is the address as seen by the server, not as seen by the client. Okay. Blah, 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 blah. Okay, start message structure. Here we go. So we are encoded in binary. So what do we think we have to do right now before we keep reading? We think part one is like send, stun, request response, request, binding request, right? We're trying to send a binding request to some stun server. I think that's what we're trying to do. So they look like this. We've got message type, message length, a couple zeros, cookie, and transaction ID. Is transaction ID client allocated or what? I guess we'll find out. I assume the cookie is, like, how do I say this? I assume the cookie is like a hard-coded defined thing somewhere in here. Stun message type field is decomposed further into the following structure. So that was this, is now this, which has a bunch of M's and C's in it. I don't know what those mean yet. The bits are shown as most significant through least significant. So this is, what am I looking at here? So this is 2 bytes. Probably big endian style, right? So this is like the first, this is the most significant bit of the first byte, I think. And so this is going to be the lowest 6 bits of the most significant byte, and then the next 8 bits, something like this. And then this is top to bottom, right? Something like that. Oh, okay, so there is, oh, I see. So all of the M's are method, and all of the C's are class. They've just kind of scrambled it for some reason. But a binding request will have class 00, so class in the... Jesus fucking Christ. Why are the bits like this? So this is in the 7th bit of byte 0. And the 0... Wait, why? Dude, oh, I see. These markers are fucking 10s. That's so funny. Okay, sure. So the, like, 11 minus 8, third from highest bit of byte 2 or something like that. Do you think you're more productive in these solo projects or in a team at work? I don't know. I think, like, structure is helpful. But, like, I think that, like, a job... Like, my last job, I was employed as, like, a full-time developer, and I probably wrote code, like, 2 days out of every 2 weeks. Maybe, if that. Right? So, like... But not because, like, I didn't want to, right? Just because, like, work is a lot of stuff that isn't writing code. So it really depends on what you, like, how you define productive. I definitely do a lot more of the thing that I enjoy doing. Like this, which is why I do it. You know? Okay. So for a binding request, we're trying to send class 00, method 1. And is encoded in the first 16 bits as 0001. A binding? Oh, sure. Hex 001. We should double check that this is big endian everywhere. Where do they talk about, like, usually they talk about a little bit byte order. Oh, here we go. Network-oriented format. So most significant byte or octet first, big endian. And then, do they talk about the bit order in here? I mean, it's usually big, so we'll just assume. Here is the cookie. Okay. Cookie. I mean, maybe we just start... Should we just start implementing now? I think starting to implement might make sense just so that we can like encode this information somewhere. Binary fields in base 10, yeah, right? Like, what the fuck? Okay. Stood debug print, or I guess return error, no. Zig run main.zig. We don't have Zig installed. That would be a problem, huh? Notes. Let's pull a Zig environment from somewhere. This is fine. This is fine. Give him a sec. He's got to think. Boy is warming up. He's warming up. Okay, we have a file. So we want to like make serialize what are we doing? We're serializing a, what are these called? Stun message. And this is going into a writer probably. Okay. So I guess we'll like say make binding request. Maybe is the easier way to do this. Probably something like this. So where were we looking at? It was like stun message structure, part 5. So we are looking for probably like write int u16 of, they said it was like 1, right? For the binding request. So, yeah, they said into the first 16 bits as this. So we go, send me a 1 big style. Okay. Then they're like, hit me with the cookie in the next 16 bits, right? No, we forgot the length. Which I guess is unknown. So there's probably like a body. Maybe the body is not owned by us, but for now we're assuming it is. If body len is greater than or equal to max int u16, or probably just greater than, we return error too long or something, and then we can write a body len cast is to u16 here with no problem. Right? So that covers the message length. Then the magic cookie should be 32 bits. Okay. So we're like, right as a U32, this guy, big style. Because we're doing network shit. And then the transaction ID is a 96-bit identifier used to uniquely identify stun transactions. For request-response transactions, the transaction ID is chosen by the stun client. For the request and echoed by the server in the response. Okay, so maybe we take the transaction IDs here and here. Am I crazy that a 96-bit int is like overkill? Like, isn't U64 big enough that like if you sent it like every nanosecond for the rest of time, you would like how many like can we look up like how many nanoseconds per year? This many. So if we have like 2 to the power of 64 over nanoseconds per year, that's 584 years. You know what I mean? Like, surely this is overkill. like, but I guess it is what it is. That's crazy. I wonder if they say why. For request response transactions, we send by the client. For indications, it's chosen by the agent sending the indication. It's primarily used to correlate, although it also plays a small role in helping to prevent certain types of attacks. Okay, the server also uses the transaction ID as a key to identify each transaction uniquely across all clients. Oh. So the transaction ID must be uniformly and randomly chosen from the interval 0 to 2 to the 96 minus 1 and must be cryptographically random. Okay, sure. So can we get like a stud IO random stud random cryptographically secure RNG? And we initialize this with the seed, and so I guess we need like we need his secret seed length. So var seed is this guy. Okay. And then I think I want to pull stud in now rather than later because we're gonna be using it. We're gonna be doing like DNS lookups and all that good shit. We're gonna be integrating with other stud projects later, so using the stud event loop is like worth it. It's worth it. So we are, what are we? Punch. Like this. We have these guys, we have stud, and our fingerprint is undefined. We try to make a build.zig where we, this is called build, who takes in a stud build. We do like, give me a stud please. And we're like, I would love to add an executable, sir. Whose name is Punch. Root module is a new module. Headless Not a Headhunter, thank you for the raid. What's up, you guys? We are trying to do some hole punching. Zefurtif, thank you for the prime. Thank you for inspiring me to be curious. That is like the highest praise I could ask for. I am happy that that is a thing that I'm doing kind of just by chance. You know? What are we doing here? We're trying to be like, pull me main. Target is target. Optimize is optimize. And we say, sir, I would love for that thing to go somewhere where I can run it. We need to pull the standard target options and standard optimize options. And then we need to say, I would like to use Spherophoria's standard library, please. So I've got a dependency, stud. I would love to link that thing. Got to run, but enjoy stream. Thank you so much for the raid. Much appreciated. Much appreciated. Root module. Add import. We're saying stud. Comes from stud. Boom. And now I think we said that this thing lives in source. So we move main over here. And he's like, sir, I need a fingerprint. It's like so true. So true, you need a fingerprint. For some reason. So here you go. I'll just put the one you said to put. Are we good? Source main.zig not found. Hello? Source main.zig. I see it right there. I see it. Oh. It's source with a space because I'm a dumbass. Okay, there we go. So now we can be like, I want to seed the seed with whatever you got for me, Linux system. Here you go. Then we're like, make binding request. So we're like, give me a transaction ID, I guess, which is going to be int in for U96. So then we can be like, I want to use that transaction ID. The body right now we're going to assume is empty, and we're going to write to some buffer, probably. Stood. IO, writer, fixed. So here, we slap that shit here. And then we should be able to just like print the thing that we made, maybe? So we should be able to be like, std debug print w buffered or something. You know, something like this. Something like this, just for now. Okay, he's mad because the transaction ID is not used, but that should be the next thing. Right? I think. U96, my bad. Okay. Okay. So this is chapter 5, I think? Yeah. So then what? The message length must contain the size of the message in bytes. Okay. Not including the 20 byte stun header. Since all stun attributes are padded to multiple 4 bytes, the last 2 bits of this field are always 0. This provides another way to distinguish stun packets from packets of other protocols. Sure. Following this are a bunch of attributes, type, length, value encoded. Details of the encoding are given in section 14. Okay. So we should have, where do they define like the binding method? This section defines the procedures of the stun protocol. It defines how messages are formed, how they are sent, and how they are processed when they are received. Okay, it defines the detailed processing of the binding method. Other sections describe optional procedures that usage may elect to use in certain situations. Sure. Other documents may define other extensions, blah, 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 blah. When formulating a request, we must follow the rules in section 5 when creating a header, which I think we did. I don't know, we really skimmed. And the method must be either binding or some method defined in another document. The method must be a method. Yes, thank you. The agent then adds any attributes specified by the method or the usage. For example, some usages may specify that the agent use an authentication method or the fingerprint attribute. All right. If the agent is sending a request, it should add a software attribute to the request. Agents may include a software attribute in indications depending on the method. Okay, crazy. But what the fuck? Okay, what the fuck does software attribute mean? You know? Extensions is done should discuss whether or not software is useful. Software! I like putting it in all caps. I don't know, it's just funny. I think he's yelling at me. For the binding method with no authentication, no attributes are required unless the usage specifies otherwise. Oh. Even if it's software? All stun messages are sent over UDP should be less than the path MTU if known. That makes sense. We should fit in a fucking datagram if we're sending it by a datagram. Developers. Yeah, it does feel like that. If the path MTU is unknown, messages should be smaller than 576 bytes, and the first hop MTU for IPv4 and 1280 bytes for IPv6. Oh, I see. So 576. Blah, blah, blah. Okay, so we're like, fix me, this should be under 576 bytes, or we should discover MTU. Sure. I guess we can be like, debug assert that like W buffered is less than 576. Len. So true. Okay. Blah, blah, blah. If the path MTU is unknown, I don't care. Some provides the ability to handle the case where the request is smaller than the MTU, but the response is larger than the MTU. Sure, we don't know how to handle that. Okay. The agent then sends the request or indication. This document specifies how to send stun over UDP, TCP, TLS, or DTLS. Okay. We may have other transports later. Okay. When running stun over UDP, it is possible that the stun message might be dropped by the network. Reliability of the stun transaction is accomplished through retransmissions of the request message by the client and application itself. Stun indications are not retransmitted. Thus, indications of transactions over UDP are not reliable. Sure. A client should resubmit a stun request message starting with an interval of RTO. So let's put a fix me in here, like set like timeout and send retransmit with rules in what chapter is this? 621. But we're like so far from this that it doesn't matter. So presumably that this is just gonna like grow. This is gonna like double every time it times out or something. Blah blah blah. Okay, I don't care about any of this right now. Receiving a stun message. I'm sure that we will just get something back, processing request, blah blah blah. Okay, I really more want to know right now, like the binding rules, you know? So is that in the table of contents somewhere? Stun methods registry. Maybe there. I think he said. Wait, they said somewhere in the chapter that it was going to be in. I can't remember though. Stun usages, maybe? No. Stun attributes? Let's just search for binding. Binding method. Okay. Here, their basic server behavior, they're talking about binding a little bit. But where do they define, like, what is in it? Did I just rap? I did. But, like, what is the binding body? Maybe it's under here. The binding method is considered to be idempotent. That's not very helpful. I'm assuming, like, is it just, like, body length of 0? Maybe. Because I assume, like, does the request have any attributes? It said somewhere that the binding did not require any attributes. And I guess is the body is attributes the body? Are those the same thing? Maybe those are the same thing. So maybe like message length, the only thing that can come over here is attributes. So like us having body as our API is maybe wrong. Software, you're right. We do need software, but it said it wasn't required. So I'm kind of thinking right now that we just huck a 0 in here. Fuck it. You know what I mean? Maybe this does a thing. And so can we try sending this and just seeing if we get a message? So I think there's like Google Stun servers. Software developer. So we have like this guy. So I think that if we are going to have some event loop, we have maybe some chained events. Maybe. At least we need somewhere to put them if there are some. We're going to want like DNS resolution probably. So this guy has some requirements. He needs us to be using like our allocator system. So just give me a second to set that up. Oopsies, this is like this. And then we have our like root allocator. And we like make one of those. And then what's he want? He wants like a name, I think. And so then we should be able to make like, we go like, here you go. This is our DNS allocator. Go fucking crazy. Do whatever the fuck you want. Here is our event loop. Go crazy. We've got a timer that we need. So we're going to be like stud IO timer service. He wants a few allocators as well. So we'll give them to him. We'll give him what he wants. He wants the event loop. And then he wants like the timer service ID. This is how we do it around here, okay? So timer will be 1. We'll say, okay. Here is the timer ID. Boom. Has the loop not been initialized yet? It's here. Maybe we have to write try here. IP leak incoming? No, we're not gonna. No. We're not gonna print the response. But I do appreciate the concern. We'll be good. We'll be good. Okay, so this guy wants a timer because I guess DNS might time out or whatever. And then this guy is like, hey, DNS service has a set of IDs as well. So I guess we'll get a little crazier. So we're gonna say DNS. The DNS event IDs come from stud.io DNS service IDs, and then we can initialize these IDs at compile time by going hit me with an ID allocator, and we're gonna go return. We're gonna return timer is ID alloc. Let's see, this should be equals. Give me one here. DNS is in it with this allocator, I think is what he wants probably. Because probably the DNS service has like a bunch of things that it might be doing. So he will use a lot of IDs, I guess. So we'll be like, you can find 10, 24 things at once if you want, sir. It's a little crazy, but you could. I'm not against it. What's he mad about? Expected struct member name found timer. What's the problem? Oh. No, I actually don't understand. Wait, yeah, now we're good. I see. Okay. We do need to instantiate the IDs, I guess. But then are we chilling? Does this guy... Oh, he's like, hit me with the DNS IDs. I need to know what they are. Okay, so we have DNS, we have timer. So we should be able to be like, while true, hit me with a loop hole forever. I think this thing can fail. And we're like, here's our event. And then we switch on the event and we're like, if it is in the DNS range, we dispatch the DNS service. Yep. Boom. And then if we are the timer, we service our timer. And he wants to maybe requeue something on the event loop or something, so we pass that in. Beautiful. And then I guess it's like else unreachable or something. This thing is failable. This thing is failable. What is he mad about? Maybe DNS service has to be variable, probably. And I guess we want to try to resolve this address, right? So can we say like DNS service, can we make a query to tell me where stonlgoogle.com is? And on response, let's say DNS complete is another thing that we're gonna do. Or I guess it's like stun DNS complete. So when we are ready, we need to do something. So we're gonna say, sir, when you are ready, call this, emit this event. And we'll say stun query handle is this. Okay, so now we should be able to be like, if we see this, let's see what he says. We should be able to be like, get this thing. And this guy probably has some like results, probably. For query results, maybe? Is that how I use this thing? Oh, it's just next. While query, I guess like while query next, we have some server. And can we just print the server real quick? Okay. Holy shit. Are we good? Expected optional type found iterres. Oh. What does this guy return? Item, wait, finished. So if we see item, we print it. If we see wait, we break. I guess it's like this. While true, we do this thing. If we're finished, we probably do something else. I don't know yet. So we'll just log. And then please God. That's annoying. I guess we break here as well. Okay, so we have a couple IPs that we could talk to stun-wise, and both of those IPs are the same. So let's just say for now, like theoretically, we could dispatch to all of those, right? We could send our stun request to all of them. Let's just take the first, right? So let's do I guess if we see item, we try to pull one. So we do this. So we say, I don't know yet. So I guess here is where we would decide to send our stun request. I guess. So we have that somewhere, right? We have our binding request. So we should be able to be like, I want to like open a UDP connection to this guy. I guess we just want like a UDP socket available to us. So this is gonna be what does this look like? We got domain, which is gonna be AFINet. Type is gonna be dgram, and protocol is gonna be 0, I think. System sock dgram, and then like system AFINet or something. There we go. And then we want to bind somewhere. So we're like, can we use 0 as our port? I hope so. Like if we want the system to pick for us, I think we can be like, just fucking pick something. Port. See this. Oh, I see. Can we see man IP? Bind. I feel like I can just write 0. When in adder any is specified in the bind call, the socket will be auto bound to all interfaces. I feel like I can just write 0. I feel like, but I don't see anything that says that. The port numbers below are called privilege. Only privileged process can bind to these ports. No, there's no concept of a port. Oh, man 7 UDP. Maybe that's something for. I'm just gonna type 0 and see what happens. Because I believe that will work, but I don't see anything that really says that. So we're looking for maybe IP4. And then what does this guy want? He wants bytes is 0000, bind to everything, port is 0. I feel like this will be fine. I feel like we will find out. And so that means that when we find our first thing, we probably only want the first one. So I guess we want to say like resolved stun. IP is gonna be like just initialized to null, and then we say like if when we get a stun DNS, I guess it's not complete. It's like notify. By the way, if the resolved IP is null, is not equal to null, we break out of this. I don't want to do this. But if it's not, then we try to resolve, and then, or we try to like get the resolution, and then we send this thing. So we say, let me send over my socket a buffer. So the thing that we wrote, flags. What are my flags? I see. I think I don't care. Oh, message no signal is pretty important. Because this will just like, if you drop the connection, or if like something goes wrong, like by default, your executables will just issue a fucking sig pipe and crash you, which is like fucking crazy. I don't know why anybody would want that, but you have to like explicitly turn that off, which is funny. And we're sending it to an IPv4. I think there's no signals for UDP. That's true. That's true. I guess this is resolved some IP as server. And then we can also use server here. And then port is whatever the fuck they said. 19302 is what I have written down there. Okay. And I guess we'll say like sent amount, and we'll just assert here for now, because I don't know what to do about this, that the sent amount is equal to the buffered length, the thing we tried to send. Sure. And we'll say sent rec to this. Okay, so we sent a request. We don't know if like what happened now though, right? So we're kind of hoping that we did enough that this will like send us a response. It's UDP, it can't really send less. Yeah, I agree. That's what, like, you know, just assert, because I don't know. So let's say that we have some notification that like UDP received something, right? And we're hoping to just see that we receive anything. That's like a big win here. So let's say, you know, we're like on this socket on read, I'm hoping to see a UDP receive, and then down here, if we see that, we're just like really fucking happy. We'll be like, OMG, he likes me. You know? What's he mad about? Oh, we didn't allocate that. ID. All right. Area union is ignored. So true. Oh my god, he likes me. He answered. Guys, he answered. Print the received body for debugging. No, don't. No. You don't get to trick me like that. No. We do not. We do not print the received body for debugging. You got no. Don't up arrow that guy. Don't up arrow that guy. I know what you guys are up to. Okay, it's gonna have my IP in there. No IP leaks. I guess we kind of did this, and we kind of did this, and we kind of did this. So we're on to record response. Okay, no, don't all guys. No. I'm not printing the received body for debugging. Okay, let's do. Well, I actually do want to do that. I think it's responding with an error. Please check. Oh, you almost got me. Let's say, uh, let's say that if we pass an argument, then we will print it or record it or something. Do replace encode to no leak. That's a bug. That's bug prone as fuck. This is the process name, so I don't give a fuck. And then we'll say leak IP is arg IT next. And we'll say or else false. And then we'll say leak IP arg. I guess it's like this. It's like leak IP is if this arg, we'll say stood. Can we check like I guess we'll just say like this has to equal like the term leak IP, or maybe true. We'll say leak IP, yeah. Okay. Sure. So then I have to specifically write leak IP in there to like freak me out. I bet it is this number. You're scaring me because like that looks like it could be a number. I hope that's not my IP. I hope you're not just like printing my IP in jet. We all know his IP is 192.168.1.2. So true. His IP is 127.0.0.1. Yeah. Okay. If leak IP, we are willing to print this thing, and we will just not type that here. Can we? So we need to do like a receive from, and this is going to go into some buffer. Okay. Const receive len is this probably. We are looking for 0, null, null probably. I don't give a fuck. Just a boolean in the code instead of a car arc. You won't mess it up, I promise. Now everybody's just posting random numbers. You guys are scaring me. Don't scare me like that. Okay. Received is the receive buff from 0 to receive len. And then if we are leaking, we type received. Beautiful. Let's first print leakies, just to be sure. Oh, and then we'll be like, else no leakies. Okay. Okay, no leakies. Good. We've got the piping correct. Correct. So we can print this here instead. And then we should be able to like build this and SCP it over to root at spheraphoria dev. Probably. And SSH root at spheraphoria dev. I think I spelled this wrong, but it's fine. Holy shit. Why is it so big? 13 meg? How do I strip this shit? .4 megs is still a lot. Can we do optimize? I guess let's build with optimizations on. Release, save. Strip. I thought I did just strip it. I thought. That's much better. Okay. Now can we run it over there? Okay. Illegal instruction. Fuck me. What type of box is this? Is this is an x86-64? Do I have to cross compile? Like, do I have to explicitly say, like, dtarget is x86-64 Linux GNU to like force it to not use things that are only on my machine? Is that your IP in the last login? Fuck. Fuck! It's all better. We fixed it. Holy shit, that's annoying. I guess I just have to like edit this VOD and cut that shit out before I post to YouTube. You guys be good. You guys be good, okay? Don't fucking do anything with that shit. Oh, it's so annoying. Okay. And we're back. Clap. You know, that's what they do. They do YouTubers clap sometimes. But now you won't know when someone else logged in on your server. Yeah, that's okay. No leakies! Leak IP. Dest open? Oh, did it not close? Oh, it didn't. SSH root, right, okay. Root at Spherophoria dev. PS aux grep sfunch. Kill 8103. I guess we should make it so that the program actually quits, huh? Alright, let's try this again. And let's run it. Oh my god, he likes me! And here's our response. Okay. Let's try parsing this. So maybe we go into... Do we have main here? Yeah, we do. Let's do like a little test, maybe? Parse response. Response bytes is a vector of U8 is like this. Okay. Timestamp? True. Sometime before now. And then all of these timestamps are actually going to be fucked because I have to edit the VOD anyways. So whatever, I guess. Okay. So let's try to parse this shit. So this is stun message structure. So what are the first, so I'm concerned that the first, oh, these are the first 2 bytes, not the first 2 bits. So the first 2 bytes are 1, 1, which sounds to me like we've got maybe this bit set, and this bit set. So we're getting class 1 or class 1-0, success response. That's really good, right? 1-0 is response. But let's just parse this thing. Let's just parse this thing and see what we get. So let's do what is this called? A stun message. And here we are looking for maybe the class and the method, which method was a U 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. U12. What, aren't there 2 bits missing here? Oh, the 2 bits are 0, 0s, right. Okay. Parse. So we're like, take int, probably, U16 big style, right? And this is the like first or whatever the fuck, what do they call this thing? Message type. So we're hoping to see that like message type shifted left by 14 should be 0, right? Zeros. So maybe like this. So we'll go like, if zeros is not equal to 0, return error invalid. We will say, so the rest of this is message, it's like this. It's like this. So it's like, class is equal to message type shift left by 1, 2, 3, 4. And 1 plus, I guess, or plus or. So this we want to shift into the second bit place. So 1, 2, 3, 4, 5, 6, 7. And this should be 2. And this should be safe. So I think that that's right. Why not pack struct with take struct? Because like I'm trying to like also unscramble the bits. You know? I'm also trying to unscramble the bits. And also like I'm not really, I don't know, I'm fine with it. Method is gonna be I guess you could, I guess you're kind of saying like you have like packed type is a packed struct who I can't ever remember which way it goes. Zig packed struct. Maybe this is the way. Which way is it? Logical sequence of bits arranged from least to most significant. So it's backwards, right? So we'll call this like method low is a U4. Class low is a U1. Method mid is a U3. Class high is a U1. And then method high is 5. And then with like zeros is a U2, and this should be a U16. And then we should be able to be like R take struct packed type big. I think. Anyways, this is kind of why I don't do this, because I'm like, this is like confusing to me. You know what I mean? Like making sure that when I'm bit shifting, I like know what's happening. Here, there's like compiler magic that I don't really understand. Like I do, like I think this is right, but it's harder to feel. You know what I mean? But we'll see. Packed type. Let's see if it looks about right. Error unimplemented, we'll say. And then let's do we'll make a reader is a stood IO reader fixed on response bytes. And then let's do a stun message parse on R. Okay. Zig test source main. He's like, yo, this has to be const. So true. And we got method low 12. Class low 0, right? So I think that this is backwards in some way. Because, like, we know that method should be 1. Right? So that makes it sound like this is bit reversed. You know what I mean? Like, all of these are, like, the wrong way. Need to remove the first. Oh, yeah, that's a good point. Fine. Fine. Method low, class high. Yeah, okay, that looks kind of right. That looks kind of right. So, class, I guess we'll say like var class is packed type class low. And then we'll say like, maybe we start with class high. And then we do class shift left by 1. And then we do class or equals packed class low. I think that this is the easiest way to get the types to work without having to do a bunch of casting, I think. Then we'll do method is a U12. And I guess we do it the same way, right? So this is like going to be pack type method high. We shift this. Oh, I think maybe this is easier. So method high is shifted left by 1, 2. I guess it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we or in method mid and low. Low does not need to be shifted at all. But the mid needs to be shifted left by 1, 2, 3, 4, 5. Class is class. Method is method. Okay. Let's return error unimplemented here in our test because we haven't actually done anything yet. And let's just print the res. All right, so we got class 2 method 1. And is that what we are wanting to see? Class 2 is success, right? So let's turn class into an enum. So we have, what is it? Zero's request. We got requests. Then 1 is indication. 2 was response, and that means 3 is error, I guess. Nice. And now we can do a enum from int here. So now we get response. Very nice. Very nice. A bit concat would be convenient here. I wonder how hard that would be getting Zig. Yeah, I mean, it would be. I'm too lazy. Is your machine big endian? You're shifting left, but it's for network order. But so we've like these bits in the packed type are like they're as if like how do I say this? Like we're seeing these 5 bits as like a U5, right? I think you've shifted the high bits too much. We'll count 1, 2, 3, 4, 5, 6, 7, 8, 9. Sounds right to me. Sounds right to me. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's right. I think it's right. But, you know, they now overlap. Who does? Oh, yeah, no, you're right. You're right. This should be. I'm shifting too far. You're right. You're right. I'm shifting to where they were in the original stream, not where they should be. You're correct. You are correct. This should be 1, 2, 3, 4 for the mid, and then 1, 2, 3, 4, 5, 6, 7. Right. So 7, 8. So here I have 7 bits from the M's. Here I have 4 bits, so I shift by 4. 7 bits, so I shift by 7. Yeah, that's. You're right. You're right. You're right. Okay. Cool. So we got those 2 pieces. I guess we forgot to check zeros, right? If zeros is not equal to 0, return error invalid. Okay, and then I think it's just like transaction ID, right? Which should be a U96. So I guess we parse the cookie. Take int U32 big style. We are trying to say if cookie is not equal to like this. So we're gonna say this is the stun cookie. If cookie is not equal to stun cookie, return error invalid as well. Okay, and then we're like transaction is try r take int 96 U96 big style, and then we're good. No field name transaction. Did I spell it wrong? I called it transaction ID, I guess. Fine. Fine, if you say so. He doesn't like the cookie, huh? C2112. I guess, can we look at what we expect to see? So we see the first. Oh, we forgot length. And then I guess we'll say length comes in here, which makes this like the message header, maybe, but like whatever. We forgot that part. Much better. Much better. Let's go, baby. Okay, so now we have 12 bytes of attributes, right? So how do we manage that? Where do they say what attributes are? Somewhere in here. TLV. Section 14. Type, length, value. Okay. So what are our types? So I guess we'll do in here, like, maybe we will keep the reader, or maybe we'll pass the reader in, and we'll say, like, next. Maybe it's just like a parse attribute. I don't know. I don't know. So we probably want to do something that's like, maybe it's more like stun attribute is a union enum. Maybe it's a struct who has his type as a enum, right? And then he's got the name, and then he's got the value. But the val should maybe be union enum because the value depends on the type, probably. Okay. So what are, like, do we have defined types? Oh. I see. He doesn't like the cookie sus. Everyone likes the cookie. So true. Oh, interesting. So how am I supposed to tell the difference between like mapped address and XOR mapped address? They're both leading zeros. Because name here maybe is the interesting part. There's no name. I don't know why I thought there was a name. So it looks like we have to like identify. We just have to identify these up front. Okay. So I guess let's start by being like while so we have like the length here of the body. So I guess we can kind of go like we can say like attr start is I don't like that. I don't know what to do here. I guess we could do like r take the length here. And then you can have like an attribute iterator that way. Where you have like a known length of these things. Maybe something like that. And then we can kind of go like adder reader. Or I guess you have limited. Yeah. No. No. So we have a attr reader here is IO reader fixed, I guess. And then we can tell when we hit end of stream, and that's the flag. Like, so we can go like while true. We can try to like try stun attribute on attr reader or something. Maybe something like this. And I guess this is just like an enum. And here we're gonna be like, I guess like catch E if E is equal to error end of stream, we break. Otherwise, we return an error. Something like that. Maybe something like that. And then, like, let's just start by doing like an R take int here of the first 16 bits. And like print that for now and then fail. Because I just kind of want to see like what the type is. You know what I mean? This is already a slice. Okay, so we're getting 32. Supposedly. So, like, what the fuck am I supposed to do with that? What the fuck am I supposed to do with that? The first, what is stun? It's like protocol for UDP hole punching. Okay. Dude, what the fuck am I supposed to do with this? Like family can be one of one or two. But I guess if we're XOR mapped, then this would flip. So if we do like we have the first byte 8 bytes off, and then we have an IPv4 address, so 1 2 3 4 5 6 7 8, and then we XOR this, but only the bottom 8 bits. That would be 1 1 1 1 1 1 1 0, which is 254, which is also not what we're seeing. We're seeing 32. Section 18.3, you're saying? Stun attributes. Ah, okay. Oh, I was looking at the body. I see. So 32, is that hex 20? Yes. Thank you. So we are saying XOR mapped address. So I guess for now, let's say that we switch on type, and if it's 20, it's XOR mapped, right? We're returning this, else return error unimplemented. That seems fine for now. Theoretically, you maybe want to return like an actual like unimplemented thing here, unknown, and he can like kind of maybe the unknown like holds the like len as well as the like data, and like lets the caller parse it. You know what I mean? So we can say like I guess here we also want the type, right? So here we return. Yeah, that seems reasonable. So we have like const len is, this should be try. And then data is try our take len or something, right? So this, at this point, we've like fully consumed that part or something. And then we can return like data is data, len is len, and type is type. Something like this. Seems kind of good. Okay. Okay, so then what is in the XOR mapped address? Wait, what was that? That was 14.2. So the family here. Oh, so this is the body. I understand now, right? So we should be seeing like the family. So I guess we should like check that the data len is the right? So data len. If data len is not equal to, what is this? This is 16 times 2? Oh, x address is variable though. How does that work? X address. If IP is IP6, then it is compute. Oh, I see. Then we want some. Right. So IPv6 is longer than IPv4. So we should check the family, I guess. So this is the second 8 bits. Sorry. Second 8 bits, not 8 bytes. So this is just data 1. I guess we should say that it should be at least if data len is less than 2, return error invalid or something. Maybe less than 4. It needs at least 4. So now we're free to look at the port and the family, okay? Then we should look at the port. And this should probably be as like a U16. Maybe like this. Okay. And then, depending on the family, so if it's IPv4, I think it was 1 for IP4. One and two, yeah. So IP4, fix me, constants, whatever. Else if family is 2, IP6, fix me constants. We'll write unimplemented here. But here we will write the thing. So I guess we're trying to return a std io net IP address. I guess. And here we're like, what was the port? The port was XORed with something. With the most significant 16 bits of the magic cookie. Okay, so we have stun cookie, shift left by 16, XOR the port. Okay. I guess this is true no matter what. Then we have the IP is here we're checking that the data len should be 4 plus 4 is 8. Okay. Then we should be able to be like, give me the U32. We'll say X IP. We have IP is X IP XOR the cookie, is what it said. And then we should be able to return XOR mapped is an IP4 address, which should be std mem as bytes. Does this let me do like big or like write, maybe write int? Yeah. So let's do this. Var ret is a std io net IP address equals undefined, or IP4 is equal to undefined, maybe like this. Then we can do write this stuff into ret IP4 bytes. We're trying to write the U32, I guess. And we're writing IP big style. Then this is just return ret, I guess. Okay, and then we're just missing the port. Okay. Wait, that seems reasonable. Okay. So we have an adder here. Can we print the adder? All right. He's like, yo, what the fuck you doing, dog? 2 to 4. There's no port here because it needs to be an IP4 port. He's like, yo, return XOR map, no good. This should be invalid if we didn't get IP4 or IP6 as our families. No field name data. Yeah, this is unknown, is this thing. Okay. So we did get that. Okay, wait, so that's good. So we got our response had one attribute of XOR mapped in it, and in there we got something probably sane here. Probably. We're hoping to see, I guess, this. Well, that seems kind of local addressy, right? Maybe that's public. Yeah, I guess that is public. So 127.227.168.167 is what we're hoping to see. Which is XORed here, so we won't know. But okay. So we're hoping, I guess, if we're running our test, we're doing a little testing, expect equal. We're like hoping that our class is response. We're hoping that our response method was 1, I think, right? I forget what. Its binding is just method 1, I'm pretty sure. We're hoping that the transaction ID is whatever the fuck whatever we're seeing, I guess. So that would be. It's gotta be in here somewhere. Let's just print it, I guess. Or I guess it'll just get mad at me. Hold on, we're getting there. All right, and then we're hoping that we get one attribute. And we're hoping that the first attribute we get is XOR mapped. Which he doesn't like here. I guess maybe we do expect here that this is like this. Yeah, he likes that. And then we should be able to expect that XOR mapped atter XOR mapped IP4, I guess. Cool. And then we're hoping that this guy's bytes is expect equal slices. And here we're trying to ping spheraphoria.dev. And we should be seeing these 4 bytes as this guy. We need to coerce, so true. Beautiful. And then the last piece is the port, which I guess is just whatever port it says, because I don't know. So he's saying it should be, wait. He's saying it should be this, which I think is a reasonable number. Okay. Parse the response, baby. Let's fucking go. So can we do a hole punch? Can we do a hole punch? So can we this is a little ugly here. Can we do like atter iter maybe? Stun atter iter. And here can we maybe do like, we're gonna take this from a reader and like a length. And we're going to have our, like, R reader. And I want to do, like, the part where we do this stuff lives here. You know? Maybe something like this. And then we can do next is going to return a stun attribute. This is a self. Something like this, right? And then we can kind of do we can do a catch E here. If E is equal to error end of stream, return null, so we can like iterate them. And then otherwise we propagate the failure. There we go. That's a little nicer. So then we can kind of, in our thing, when we get our response, if we have leak IP on, we can start printing out what we got, right? And I guess we need to detect if it's a stun message, right? So we need to say, like, if this is a stun message, what was that? Was what? Otherwise, here we're gonna say received other message. And can we print it as a string maybe? So the hope here is that we will print out the stun header. We then will then be able to send a UDP message from our computer to here and see what we wrote. That's what I'm hoping to see here. So he's mad at the unused capture. So we just have to do the rest of this part where we say, give me the stun iter. Okay. What does he like here? Expected optional type? Oh. You need to write this. Okay. So then we have var attrs next. So this should be the, like, while we get this, we switch on it. And if we see an XOR mapped, we print it. Maybe. Right? So we're like, we UDP socket at wherever the fuck we're at. So number port number. And here we're like IP4 byte 0. Right, we're just like slam these. Okay. That seems like something. Okay. We're getting closer. Okay. So if we build this now, and we copy paste it onto our server, so we got this guy, but we need to stay open now. We need to stay open. We're not dunsies anymore. You know? So can we... Why is it so big? 13 megs. Oh. Wait. Shouldn't that be fine? Oh yeah, okay. SCP. Oh, I probably built in my editor, which built in debug. Okay. So if we go here now, and we do a little Run this guy? Oh, but we need leak IP. So we should be able to like netcat to this guy now. NC to this guy. This port. Can I say netcat UDP? Hey, you guys aren't supposed to be sending. This is my job. I'm supposed to be sending. Hello, world. Let's fucking go, baby. Oh, wait, hold on. This is the public IP. So, can we do this from a network namespace? That's the interesting part. So we should be able to like leak IP. We should be able to do this with 47478. Oh, he doesn't like that. Interesting. Interesting. So it could just be that the hole punching doesn't work in the VLAN setup I have. That's like very possible. Because like as far as like my understanding of the network stuff goes, we have sent a message out and the UDP socket is still open there. So he should be able to like receive stuff. The fact that he can't is a little awkward. So also it's interesting here that netcat knows. You know what I mean? Like why is he quitting? I think it's not actual hole punching, it's just an IP port from where the request came. It's not open since it's just UDP. Yeah, but like, so the way that this is supposed to work, as far as I understand it, is that the like routing table in the router like knows that someone is gonna try to answer him, and he should like keep that hole open. Right? Like here, this response came from a UDP message from someone, right? So I wonder if it's like a firewall rules thing. Right? Like, what did I do here? What did I do here? I just asked the fucking idiot how to set up a like VLAN. So maybe we'll just ask the idiot again. I'm trying to test UDP hole punching using stun. I set up a VLAN on my VPS which has a public IP public interface to simulate NAT traversal with the following script. If you ask the idiot for help, what does that make you? Yeah, I know, but he can give some ideas. Is it expected? I am getting stun responses over UDP, but if I try to send UDP messages from another host, it does not seem to accept them. Am I missing a firewall rule or something? Let's see if he gives us an answer. You're close, dude. Shut the fuck up. The fucking affirmations from ChatGPT always piss me the fuck off. Enable forwarding. Ensure input allows. Oh my god. And then here we've got like net filters. If you expect external hosts to be able to send directly, blah blah blah. I mean, this sounds maybe. So I did this. They're saying. No, this is port forwarding, right? I don't want that. I don't think. You're so close. Almost there. Hang in there. Make sure contract is tracking UDP. Oh, yeah. Let's check that. That sounds like what I'm asking for. Can we look at like what this is? 30. Okay. I mean, that makes sense because um we are getting the response at all from the guy we're talking to. So it's more something about like allowing like random ports. Which is like maybe this? Can you tell me what the fuck this does? Uh what the fuck does this mean? um So without the first rule, you let me drop in the forward chain. Without the second rule, replies from remote host may be dropped because the forward blocks them unless they match an existing connection. Ah, that is the one I want then. I want the second rule probably. 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 He's saying allow forwarding. Okay, well, let's just see what happens if I do that. You never know. 57881. Hello. No luck. Oh, Iliante, thank you for the 10 gifties. Holy shit. Holy shit. Thank you. That is very kind. Very kind. Yeah, okay. Interesting. Interesting. Ensure input allows the external UDP ports. So he's like, just allow literally anything? I mean, maybe. Except, oh, no, I don't. Okay. Well, I think that the problem is more like a hole punching issue than it is a... Like, I think like the stun stuff is working. Check NC on your side. But like, it worked. So the thing is, it worked when we were outside the namespace, right? So if I did a punch here, and then we did it with this, right? This was working. I also don't understand how it knows that the packet's rejected. You know what I mean? Like when I go into the network namespace and I run the same thing, like, how does he know to kill himself? That's kind of weird. Because I would expect that, like, how do I say this? I would expect him to just, like, blindly send it and then never think about it again. Right? So, like, there must be some response coming in somehow, but I just don't know what that is, because it's not like a streaming connection. Is there a verbose flag? Yeah, maybe. Can we... Maybe not. Man, NC. Verbose. It does say produce more verbose. We can ask the idiot maybe. If I use netcat-u to talk to this server, it instantly closes after sending the first line in the case where the network namespace isn't accepting connections. How the heck does it know? Oh. So I see. So the firewall might just be like hard dropping it and we're getting a connection refused there. Interesting. Yeah, so I don't expect this. It does really feel like it should be these rules, but so I tried the firewall. Maybe I didn't put them in the right context though, because I kind of executed those IP tables commands from in the namespace. I don't really know if that fucks shit up. So let me just like double check here. Can I like IP tables L? Um. So it does seem like we're missing these rules, right? Yeah, we were missing them. So I think that I had to execute them from outside the namespace, maybe? I don't really know how this shit works. But that seems more reasonable. Maybe. Are those duplicated? I can't fucking tell. Maybe those are just duplicated. What does -tnat do? Can you even talk to that address from a different namespace? As in, do you have an interface that namespace can route packets there? I mean, so how do, like, it feels, maybe I'm stupid, but like the fact that I get a response from the stun server makes me feel like something is working, like that there's some routing happening. But like I have like really no idea what the fuck I'm talking about here, so maybe I'm missing something. You're saying do IP tables -tnat. Yeah, so there's like nothing, I guess. Which is like what he's saying to do down here. He's trying to say something like allow. If you expect external hosts to send directly to the internal IP addresses, which I don't. So that's not what I want, I don't think. I tried some of your firewall rules and it's still rejecting the packets. Okay, let's debug step by step. Shut up! Confirm IP tables rules. So what does this do? What is IP tables -s? Verify kernel forwarding. Sysctl. Oh, he already said that part. That's off. So do I need that on? Oh, am I in the namespace again? I am. Fuck. But it is off. Maybe that needs to be on. What does that do? Sysctl IP for forward. What does it mean? To enable IP forwarding, which is essential for running in NAT functions, that sounds important. That sounds important. That sounds important. Let's try again. Four, 3, 4, 7, 4. The fuck? 47709. Still nothing. Still nothing. You need to add some NAT rules, so those -NAT rules are required. But like, I mean, okay, maybe I don't really understand what these do. It sounded to me like those weren't what I wanted. But I guess maybe we do allow it. So this is 192.227.168.167. Port-J does not, but like, maybe, because like this feels like it's like port forwarding, which I don't really want, right? I want like automatic port forwarding. Okay, well, I don't understand. I'm just like randomly typing shit, so this isn't very useful. I think what I want to do is I want to test on like my machine, but like I can't demo that here because I will leak my IP again. So like our machine. Okay. So I think what I'm gonna do is I'm gonna call this a success because we are like sending and receiving our stun messages, right? And they just we're just missing like the actual hole punching part. But like that's an environment setup problem. So I think we call that a success and say, good job us. We parsed a stun and we sent a stun. Wowzer, wowzer. And we've done, the first piece. There's probably some sort of like connection keep alive that we're supposed to be doing. But I think that should be pretty easy to implement later, right? We saw some sort of like RTO, retransmission timeout thing that we're supposed to be doing. Dude, whole bunch of words because of NAT. NAT is indeed automatic port forwarding. That's what I'm saying. I think. How do I? So my understanding of the word port forwarding, which is maybe wrong, is that like I am like on my router, I go into the port forwarding and I say port forward this port to that port in the like internal LAN to this IP, that port. But like I just don't know what all of these IP tables commands mean. So if they're saying like, hey, port forward to things that already have holes punched through them, like that's fine. But if they're saying like just forward all traffic to this IP with like the ports mapped, like I don't know what it means. So I have to do reading for like what all of the like commands mean. Like obviously the routing from random IP port combos back is not working correctly, but I just don't know like I don't know the terminology and like the commands to make that work. You know what I mean? So like I believe you. I agree that I have to set something up. I just don't know what the names for those things are, and I think that me just struggling to spam them. Port forwarding is when you bind exact port in your internal host and external IP. That works automatically. It just remembers which port was opened. That sounds like my understanding, yes. I'm just, my confusion is coming, like, I'm not saying that you're wrong at all. Right? I'm saying that I look at this command and I'm like, I have no fucking idea what it says. And so like this, and here when I copy paste this, it goes like, you're trying to forward, like, he's like deport is looking for a specific port. I'm like, I'm not trying to forward a specific port. I'm trying to forward like whichever random one, right? So I'm just missing something, which is fine. You know what I mean? It's fine. Anyways. Yeah, the retransmission stuff should not be too hard, right? It's just like you need a handle that gets serviced every some time. Dport tells it to modify destination port packets, but then like the command that it was saying, it was erroring out saying that like the port was wrong. I don't know. It's fine. I believe you. I believe you know more than me, and I believe that you could make it work. I'm just saying I don't want to waste the time trying to figure it out right now. You know what I mean? It's fine. Yeah, we called it a win. Thanks for watching. If you like what we saw, we have seemed to have settled into an every other day streaming thing. I don't really know how that happened. It used to be more often. Maybe it will be more often again. We are working on this SIP client, and one of the things that we were doing is trying to do some networking, but there's other stuff. We're doing RTP, we're doing SIP, we're doing audio, codecs, all that good shit. So swing back by if you want to see more. I need to answer my door someday, so we have to finish. Yeah, I think that's it. YouTube, peace out. Twitch, let's find someone to raid.